Good morning and welcome. Today we are going to learn about the first chapter under electronics engineering. The course is applied science. The topic is called units and measurements. Your presenter is Manuel Kelvin, a lecturer at Mathura Technical and Vocational College. Welcome. As you can see, there is a very interesting photo at the top. There's this gentleman trying to get some measurements over his radar. And basically we can assume he's an engineer or he has some engineering concept and is well adversant with units and measurements, and that's what he's trying to practice. In one or the other, we are going to get just the basics of what he's going through under measurements. On the second slide, we have the weather forecast. In this case, when you're doing weather forecast, we look at the number of effects, we look at the temperature, and the amount of rainfall we expect. In this case, the temperature can be measured in degrees centigrade or in Fahrenheit. For example, you look at New York, the highest temperature expected with at 1 degrees, the lowest temperature expected will be 16 degrees. That's it for today. Tomorrow there's a different figure, and the other day there's also a different figure. What are we doing here? Basically, we are doing measurements, and we are taking measurements and interpreting measurements. That basically means measurements is like our daily language when it comes to taking data, and also is very vital in engineering. Now we have something or some other concept called SI unit. What does SI mean? SI basically means System International Relay. It is a French word which means international systems of units. Basically, this is an agreement upon engineers, upon mathematicians, and all professional interested in measurements, whereby they have to, among all the units that we have, they have to have standard units that represent given measurements. For example, we have the SI units for mass, the SI unit for length, the SI unit for time, and what have you. So that was meant by SI units. Then there's another concept called the metric system of units. This one you have heard it before, and want to understand why it's very easy to use metric units of systems. Now, the standard measurements used in science are those of the metric system. All metric units are based on multiples of 10. As I'll start, you can convert them between each one easily. For instance, we can have, for example, we have centimeters, converting it into meters. That's a difference of 10 or a multiple of 10. That's 10, then 100. For example, you can also have millimeters to centimeters. There's also a multiple of 10. That's what we mean by metric systems are easy to use. There's easy conversion between the two symbols, the two metric units. For example, this is 10, and the unit here is meters. So that's what it means to be 1 or 10 centimeters, for instance, times another 10 centimeters. You get what? You get to 100 centimeters. You get to 100 centimeters. Now 100 centimeters is equivalent to what? Is equivalent to 1 meter. This is what we mean by a basic of 10, or basic of 10, or multiples of 10 centimeters each. More on the metric units. The metric system was originally established in France. That's in 1795. And the International Units of Systems, abbreviated SI, that's a French name, was a revised version of the metric system, and it was adopted in the International Agreement of 1960. That's fairly almost around 80 years ago, and that's how it has been used all along. Now, there's another concept I want you to get about. We call base units. We can also call them primary units or primary units. What are these? There are 7 in number. These are the units that which we get all other units from. The other units apart from this are called derived units. For instance, we'll start by naming the 7 base units, looking at the base unit. There's the quantity, there's the base unit, then there's the symbol. The first quantity is length, which is measured in unit. The symbol is small m. The other quantity is mass, which is measured in kilograms, and the quantity, the symbol is small k, small g. Then you have temperature, which is measured in Kelvin, and the symbol is capital K, and so on and so forth, as seen in my table. The other quantities are time, amount of substance, luminous intensity, and the last one is electric current. These are the units of which we get all other derived units from. Now, from that, we shall look at a few other concepts, or at a few other sub-concepts. That's the unit of a length. The unit of a length in SI, the basic unit of a length or linear measure is the meter, as you have said in the previous slide. All measurements of length can be expressed in meters. For a very large and very small lengths, however, it may be more convenient to use an unit of length that has a prefix, and that's what we are calling metric systems. For example, a meter can be expressed into millimeters by multiplying by 1000, and so forth and so on. Then here I'm basically giving a table of units of length with given common prefixes. For example, mega is a capital M, which basically means we are multiplying by a factor of, or multiplication factor of 10 power 6. Then have a kilo, multiplication factor is 10 power 3, and so forth and so on. I'll go to a micrometer with a multiplication factor of 10 power negative 6, and so forth and so on. Then I'll move ahead. Furthermore, these are more examples of the units of length and their multiplication and their conversions. Then we also have the units of volume. Volume is a derived magnitude or derived quantity, and this unit is meters per cubic. That's also a derived unit. And there's also more examples that I want you to look at, and how we convert the different derived units of volume, and so forth and so on. Also take your time to look at these and more other samples. I would like to stop at that point. We shall proceed it in our next presentation. Thank you.